Today we're going to look at similarity in specifically right triangles and how you can find proportions within those right triangles. So the altitude, which we've talked about before, is the same thing as a height. So it has to be perpendicular, which we see happening down there. So the altitude of a right triangle creates three similar right triangles. And the right triangles that it creates, we have one here, we have one here, and we have the whole thing. So let's look at how we would rotate those triangles to all face the same way. Let's give us some letters. Call this A, B, C, and D. So we're going to rotate them so that they're all facing the same way, like that. So that can be one of our triangles, and we can call that, we can do this triangle. So if we have it facing that way, our right angle is here, and then that shorter side is going to be that shorter side in my picture, so that would be A, D, and then B would be over here. So the next triangle, we can do this one. And that one's almost already facing that way, we just kind of have to flip it the other way. So this would be D, this is B, and then this is C. And then our last one, which would be the whole thing, our right angle is at, let me draw that again to make it look a little bit more drastic with the shorter side and the longer side. So our right angle is at B. The shorter side of the triangle goes from B to A, and then out to C. So those are the three similar right triangles that you get from using it, having an altitude in one right triangle. We're going to figure out why those right triangles are similar next. So we're first going to look at trying to prove that triangle BCD, so BCD is this triangle, and triangle ACB, which is the whole thing, are similar. So let's start out by drawing those two triangles, rotating them so that they're facing the same way. So if I have the short side there, long side, hypotenuse. So our right angle for the orange one is at B. Shorter side goes through C, and then the long hypotenuse comes out to A. And then our green one, short side, long side, hypotenuse. Right angle is at D. Short side goes to C, and then we come to B out here. Alright, so let's see what we know. We know that angle B and angle D are both right angles. So angle B has to be congruent to angle D because all right angles are congruent. And then looking back at our picture, both of those triangles, when they're facing how they are in the picture, overlap and share angle C. So that's something else that I know. Angle C is congruent to angle C by their reflexive property, which then is enough to say that triangle BCD is similar to triangle ACB by angle similarity. So now I want to look at two different triangles. I want to prove ABD and BCD. So this one's a little bit trickier. So triangle ABD we have right there, and then BCD is this one. So I'm going to redraw those triangles so that they're facing the same way. So this is B, D, A. So our right angle in the green one is at D, the shorter side is C, and then comes out to B. Now, like in the last example, the triangles do not overlap at an angle. Yes, we have the right angles at D, but we don't have another angle that we can use. So we can list the right angles. Angle, I'm going to put some numbers there. Call this angle 1 and angle 2. Angle 1 is congruent to angle 2, because all right angles are congruent. But that's all we really have so far. So to help us, I'm actually going to use a third triangle, the bigger triangle, triangle ABC. I'm going to rotate it around so it's facing the same way. So our right angle for that one is at B. And shorter side is C, comes out to A. So now that I have that third triangle, I'm actually going to go back to what we wrote in the first step and add in another right angle, because these are both congruent to angle B also. Okay, so now at this point, I know that with the blue and the orange triangles, they both overlap at angle A. So angle A is congruent to itself, and then the blue and green triangles both overlap at angle C. So angle C is congruent to itself. So those are both by the reflexive property. So now I'm able to say, not the triangles I'm trying to prove yet, but I can say that the blue and the orange are similar because they both had angle A in common. And then I can also say that the blue and the green are similar because they both had angle C in common. So I can say that triangle ABD is similar to triangle ACB, and I can say that triangle BCD is similar to triangle ACB. Those are both by angle. So now, looking at what we have, triangle ADB, I want to end with. Triangle BCD, I want to end with. And what we have is that they are both equal to the same thing. So if two different things are equal to the same thing, then they are equal to each other. So triangle ABD is similar to triangle CD by the transitive property. And that's it. You're done. You proved what you wanted to end with. Okay, so now we're going to put some numbers with it. Look at our three triangles. So we have the one on the left, the one on the right, and then the whole thing. Draw them all separately. Alright, so the whole thing, the right angle is at B, shorter side goes to C, and then to A. The green one, right angle is at D, shorter side goes to C, and then comes out to B. Blue one, right angle is at D, shorter side is at B, and then comes out to A. So now that we have the triangles drawn separately, let's put the information into the pictures. So AD is 3, and I don't have any other ADs. BD is x plus 3, so this is x plus 3. But we also have another BD right here, so this is also x plus 3. And then CD is 5x minus 3. So now that you have the triangles separated, it's a lot easier to see what the proportions would be. So x plus 3 would go over 3, and then 5x minus 3 over x plus 3. Now, as you see, I have the same expression diagonal from each other, and that's always going to happen. So if you don't have that, something may have went wrong. So then from there we can cross multiply. 15x minus 9 is equal to x squared plus 6x plus 9. So I want it to be equal to 0. X squared minus 9x plus 18, which can factor to x minus 6, x minus 3. So that means x equals 3 and x equals 6. And they would both work. Okay, so let's look at another example. We're going to make sure we draw all of our triangles outside and rotate it. So the orange one, right angle at B, shorter side goes to C, comes out to A. Our green one, right angle is at D, shorter side is C, comes out to B. And the blue one, right angle is at D, shorter side goes to B, and then comes out to A. So now let's put in the info that we have. AC is 10. I don't have any other ACs. BC is x plus 3. But I have another BC here, so this is also x plus 3. And then CD is x. So those proportions set themselves up for you. So I can have 10 over x plus 3 has to equal x plus 3 over x. Once again, we have the same expression diagonal from each other, so make sure that happens. So now let's cross multiply. And you have 10x equals x squared plus 6x plus 9. Set it equal to 0. So x squared minus 4x plus 9. So I don't see anything that I can factor here. I'll use the quadratic instead, so I'm going to erase those pictures. And our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is A, this is B, this is C. So negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 9, all over 2 times 1. So it becomes 4 plus or minus the square root of negative 20 over 2. You cannot take the square root of a negative number, so our final answer for this is no solution.